Okay, here is warm-up 9.5 to 9.8, R.1. Okay, so we're going to use the unit circle to find the exact solution for theta within this range between 0 and 360. 0 is included, 360 is not. So all I need to do on this first problem is know that I'm going to be looking for the y coordinates. On the unit circle, sine is going to correspond to the y values. So I'm just looking for angles that have a y value of root 2 over 2. So looking around, here's one right here, okay? That's, sorry, this is hard to see, this unit circle on there, but the y there is root 2 over 2, and so that's at 45 degrees, so theta could equal 45 degrees, but I'm looking for other places that have that same y value, so I'm thinking, are there other places that are at the same height, because the y value is going to correspond to the height of this point. Well, there's another place right over here where the y value is also root 2 over 2. That's going to happen at 135 degrees. So there are two places on the unit circle. I'm going to try to focus my camera a little bit so we can see that unit circle a little better. Okay, so I've got two places. Those are the only two places on the first go around on the unit circle that are at that same height. So that's it. Okay. All right. I'm going to be looking for degrees again on this next one. First thing I want to do is isolate cosine. So I'm going to add 4 to both sides first. Now I've got 6 cosine theta equals -3, and then I'll divide by 6. So now cosine theta will equal -1/2. And now I'm going to be looking for y values for different angles on the unit circle where, x values for cosine, where my x is -1/2. Okay, so I'm looking for x values of -1/2. Well, that's going to happen up here. That's at 120 degrees. So I'm looking for also another place that's going to be 1/2 to the left. Well, you could go 1/2 to the left and then up, or you could go 1/2 to the left and then down. So there's these 2 points that both have an x coordinate of -1/2. So that would be at 120 degrees, also at 240 degrees. Okay. If you use your calculator, say you could do inverse cosine of -1/2, it's only going to tell you one of these. Okay, so let's just try that out. I want to make sure I'm in degrees here. I am. Okay, so I do inverse cosine of -1/2, and that's going to give me the 120, but it won't give me the 240. So you have to know that your calculator will only give you one of those and how to find the other one. Okay. All right, so this next one, I've got an equation that has two different sine terms. This one's squared, this one's not. So I still want to solve this for sine. And what I'm going to do is think of this, well, what if I had x's instead of sines? Well, this would be 1x, and this would be 2x squared, and this would be there, -4 minus 3. Well, if I wanted to solve this, what I'd want to do is set it equal to 0. I'm also going to put the x squared term in front. I'm going to rearrange the order of the terms there a little bit. I'm going to be adding 3 to both sides. Now I've got it equal to 0, and I've got a quadratic equation. So what I'm going to do now is factor this. You could complete the square, do a quadratic equation, but when you can factor, I think that's the easiest way to get your solution. So I know it's going to look like that, right? It's going to be 2x times something. And then I can factor this pretty easily just in my head. You could do a modified diamond problem or something like that, but I know it's going to have to be 1 times -1 for the lasts. So I just have to figure out which of these is positive and which is negative. So if I think about it, well, if this one was positive, then I'd have 2x minus 1x. Well, that would give me positive 1x. So I need this one to be negative and this one to be positive. So then my outer and inner, I'd have negative 2x and positive 1x. That would give me that middle term, okay? So now I can say, okay, zero product property, either 2x plus 1 equals 0 or x minus 1 equals 0. And that means, let's see, 2x would equal -1 and x would equal -1/2. And over here, x would equal 1. Now, I had replaced the signs with x in the beginning of the problem. So let's put sine theta back in. So now I know sine theta equals negative 1/2, or sine theta equals 1. So now I can look for places on the unit circle where the y values are negative 1/2 or positive 1. Okay, so from this one, let's see what we get here. So negative 1/2 for y. Negative 1/2 for y. I've got one there, and I've got another one over here. Okay. Now, you could say that that's 210 and 330 degrees, but the way that this is written here tells me I'm looking for radian measure. Okay, so you see the way it says 360 degrees on the first two. This time it says 2 pi, so I'm looking for radians. So that's going to be 7 pi over 6 or 11 pi over 6. Okay, so that comes from that first equation there, but I've also got this one. So let's see. I need a y value of 1, and that's going to happen at 0, right? 2 pi is not included, but 0 is included. And so there is my last value. Okay. All right, this last one is the trickiest of these because I've got sine in here, and I've also got cosine. So before I would substitute in an x, you have to get one variable. So I want to write this with just sine or just cosine. So what's catching my attention is the sine squared, because I can use a Pythagorean identity. So to write that in terms of cosine. So sine squared theta plus cosine squared theta is going to equal 1. So I'm thinking, okay, I could just subtract cosine from both sides. In order to isolate sine squared. And now this quantity is going to be equivalent to sine squared. So now I can replace that with 1 minus cosine squared. So that's what I'm going to do. So I've got negative 3 cosine squared theta minus 2 plus, and then I've got the quantity 1 minus cosine squared. Okay, and now I've only got cosines, so that's better. Now I could use an x or a variable if you like, or you can factor it with the sign in there. I just use x's because I think most of my students are more used to factoring something in this form rather than with sines in that case, or cosines in this case. Okay, so let's start collecting like terms. This would look the same without parentheses here. So I've got a negative 3 cosine squared and a negative cosine squared, so that's negative 4 cosine squared. Negative 2 and 1, when I combine those, is negative 1. Okay. Now, I'd prefer my squared sign to be positive, so I'm going to pull everything over to the right, actually. So I'm going to add 4 cosine squared to both sides. And then I'm going to add 1 to both sides as well. Okay? And at any point, if you like, you can replace this with x's if that makes you feel more comfortable, right? And you just have to remember to put it back in at the end of the problem. Okay? So, need to factor this. So, factoring this by hand, the parentheses are going to start with either 4x times x or 2x times 2x. So I got two options. You could fiddle around with it, or you can do a modified diamond problem if you like. So that's what I'm going to do. So I'm going to do 4 times 1 here. Okay, now I'm going to use a diamond problem here. So I'm looking for two numbers that add to 4, same two numbers multiply to 4. That would be double 2's, right? And so this is going to factor into x plus 2 times x plus 2. I'm writing a little small because I'm running out of space here. And now since I modified this trinomial, I got to modify my answer. In the beginning I multiplied by 4, so now let's divide the constants by 4, just the number bits. Okay, I'd want to reduce both of those as much as I can. And since I still have a fraction on both of these, I'd want to pull the denominator out in front of the x. So now I've got 2x plus 1 times itself, times 2x plus 1 So this is what 0 equals. Now I've factored that trinomial, okay? So both of these factors are the same, so I don't need to use them both, but when, let's just use this one. So if 2x plus 1 equals 0, then 2x equals -1 and x equals -1/2. Now, I got to remember, I started out with cosine for x, so I've got cosine theta equals -1/2. Okay, now I'm in business. I'm looking for an x value of -1/2 on the unit circle. I'm going to be using radians again. So I know that from right there. Okay, so x value of -1/2 is going to happen up here at 2 pi over 3, but also right below that at 4 pi over 3. So 2 pi over 3 and 4 pi over 3 are what I'm looking for. Okay, and I ran out of space at the bottom there. Well, yeah, I'll put it right here. 2 pi over 3 and 4 pi over 3 are my solutions. And there we go. All right, that's the end of the warm-up, and I'll see you next time.